In the uniform electric field, an electron is accelerated from rest. Charge in electric field, acceleration. So acceleration is q e by m. And then velocity of the electron when it has traveled a distance, v square equal to u square plus 2as. Fine. From rest means initial velocity 0. Substitute this in this. Velocity square equal to 2. Acceleration is q e by m. Let this be charge of electron. Okay, instead of q, e. Displacement, displacement. 2 e by m is given. Observe. 1.8 10 to the power of minus plus 11. Electric field is 10 to the power of 4. Displacement is 2 10 to the power of minus 2 equals. Left hand side is velocity square. Students, when you go through the problem, when you read the problem, take 1 or 2 seconds time and go through the options. You can see this. Means don't worry about 10 to the power of. Next observe 8 5 8 5. So we should be little careful when we solve. See, 2 into 1.8 into 2, 2 to 4, 18 7.2. 2 into 2 into 1.8 is 7.2. 10 to the power of 11, 4, 15, this is 13. Give 1 0 to this because it is odd number. 1 0 to this. Root of 72, root of this is, because we want velocity, root of this is 10 to the power of 6. 64, 8 square is 64, little more than 8. So 8 point something into 10 to the power of 6. Fourth option. So it is given 8.5, so it should be 8.5. Two identical metal spheres charged are kept at certain distance in air. They are brought in contact and then separated. Ratio of magnitudes of electrostatic force between them before and after. 12 minus 8. These two are the charges. When they are brought in contact, 12 minus 8 is 4. Again, when they are separated, this 4 becomes 2 and 2. Force is directly proportional to product of the charges. So just find out product of the charges. So force before is proportional to product of these two. 12 into 8. Force after the contact, product of these two. 2 into 2. Now divide one by the other. 4 1, 4 2. 12 into 2, 24 by 1. So force before by force after is 24 by 1. 24 by 1. If a charge on the body is 1 nanocoulomb, then how many electrons are present in the body? Quantization of charge. Q equal to N into E. N is Q by E. Charge is 1 nano, 10 to the power of minus 9. Charge of electron is, magnitude of charge of electron is minus 19. This ratio is 10 to the power of 10. See, 10 to the power of 10, this is close to 10 to the power of 10. 1 by 1.6, 1 by 1.6, you know, it is 0.625 into 10 to the power of, give 1 0 to this, it becomes 6.25, 10 to the power of 9. See, for simplification, you really don't require mathematical table or calculator. So the options are set beautifully that even without calculator you can get the answer. If the options are very close to each other, like 6.25, 10 to the power of 9, one more option, 6.45, 10 to the power of 9. So in such cases, you have to be a little bit careful. Okay. Two equal and opposite charges, masses, are accelerated in uniform electric field. Let this be uniform electric field, E. One is positive charge, the other one is negative charge. Positive charge experiences force in the direction of the electric field. Negative charge against the direction of the electric field. What is the ratio of their accelerations? Acceleration of a charged particle in electric field. So acceleration is QE by M. Equal and opposite charges. Don't worry about charge, magnitude of charge. Electric field is constant. So these two are inversely proportional, isn't it? Look at the options. We want A1 by A2. A1 by A2 is M2 by M1. Why M2 by M1? Inversely proportional. But M1 by M2 is 0.5. Therefore, M2 by M1 is 1 by 0.5. This is 1 by 0.5. 1 by 0.5 is 2. So answer is 2:1. What is the nature of Gaussian surface involved in Gauss law of electrostatics? Gaussian surface gives area, and area is treated as a vector quantity. Why area is treated as a vector quantity means it satisfies the laws of vector addition, isn't it? So it not only gives magnitude, it also gives direction such that it follows the laws of vector addition. Therefore, it should be a vector. A spherical conductor of radius is uniformly charged. What is the electric field at a point 3 centimeter from the center of the sphere? So here is a sphere charged, radius is 2 centimeter, but point is at a distance 3 centimeter. So R equal to 3 centimeter, point is outside the sphere. Gauss theorem, application of Gauss theorem. Electric field is given by constant, charge by distance square. Charge is 9 10 to the power of 9. Constant is 9 10 to the power of 9. Charge 3 nano by distance square. Distance is 3 centi, 10 to the power of -2 square. Electric field. 3 square 9. This 9 get cancels with this 9. Remaining is 3. 10 power 9, 10 power -9 gone. 3 -2 square is -4, goes to numerator. 3 10 to the power of 4. 3 10 to the power of 4. If questions are very easy, then try to solve in less time and use that time to solve some other question which consumes more time. Okay. And if the question is simple, then don't spend more time in simplification and cross-verifying the answer. Don't kill time. Angle between dipole moment and electric field at any point on the equatorial plane is 180 degree, isn't it? Electric field at a point on the equatorial plane is constant minus P by R cube. This is the equation. This negative sign says these two are in opposite directions. That's why 180 degree. Now let me use diagram. Positive charge, negative charge, dipole, a point on the equatorial plane, This is the equatorial plane. Because of positive charge, electric field is away. Because of negative, towards. Resultant of these two will be in this direction. And what's the direction of electric dipole moment? Stick to basics. It is always from minus q to plus q along the line joining the charges. So this is P cap. P cap, and this is resultant electric field. And these two are in opposite directions. Therefore, 180 degree. Either use equation or use the concept. Pick out the statement which is incorrect. Students, when you read wrong statement, incorrect statement, please try to underline this. Okay? Because often we go to the correct option because we are trying to get the correct answers, isn't it? But if incorrect or wrong options are asked, then we should be careful. Electric field lines forms closed loop. No, it doesn't form closed loop. Only magnetic field lines form closed loop. This is incorrect. Therefore, this is the answer. Since it is practice session, let us check other options. Okay. Field lines never intersect. Statement is correct. Therefore, we don't want. The tangent drawn to the line of force represents the direction of electric field. True. Statement is true. We don't want. A negative test charge experiences a force opposite to the direction of electric field. Negative charge opposite. Positive charge in the direction of the field. Correct statement. We don't want. A. Two spheres carrying charges separated by distance experiences a force of repulsion, plus and plus. When a charge is given to both the sphere and kept in the same distance as before, the new force of repulsion is. So force is directly proportional to product of the charges. Fine. Initially 6 and 9, of course micro. You don't have to write micro every time. This is 6, this is 9. So product of the charges is 6 into 9. This is force before. A charge of -3 is given to both the spheres. -3 is given. We want new force. When -3 is given, so this becomes 3. -3 is given, this becomes 6. Product of charges after. Force after is proportional to 3 into 6. See, force after is 3 into 6. Force before is 6 into 9. Divide one by the other. 6, 6, this 1, this 3. So force after or new force is force by 3. F by 3. Just little practice will make you write in this format. Sometimes we take before and after. Since after, force after contact is asked, therefore try to write this first and then this later. Thereby you can really save some time. So it is F by 3. If there is only one type of charge in the universe, only positive or only negative, then E is electric field, ds is area vector. This is flux. Integration, total flux. Total flux is not equal to 0. on any surface. Could be. Flux could not be defined. Yes, we can define. Therefore, this is not correct option. Flux equal to infinity. No, when charge is not infinity, flux cannot be infinity. So, not correct. Flux is 0 if charge is outside. True. If charge is outside, only one type of charge, then flux through this surface is 0. So this is right. If charge is inside, then flux is q by epsilon naught. Positive flux means outward flux. Positive charge means outward flux. So this is more appropriate than this. So please don't consider. And what is wrong with this? On any surface, the position of charge is not mentioned. Is it on the surface or outside the surface or inside the surface? And that is pretty much clear in this. So that's why fourth option.